Actually, before we even do that, I did want to just say thank you guys for all the feedback you've been handing off to the TLs. I am, again, trying to get my sea legs back in order. This is a little bit different from teaching endorsement, but I think with your guys' help and patience and feedback, I should get back into it pretty quickly. So again, keep the feedback coming. I just want to let you all remind you all to definitely try to make it constructive and professional. But other than that, yeah, let's go ahead and get started. So today I thought we'd go over real quick the exercise on comprehensions, on dictionaries, and then on classes. Just kind of, well, those were kind of picked arbitrarily. If there are maybe other exercises you would also like to see me work through, we can carve out some time tomorrow to go over that as well. If you kind of like either DM me what you'd like to see tomorrow or pass it up to the TLs, I think either would work. But these are the ones we're going to go over today. Okay. So starting here with list comprehensions. First off, want to go ahead and write a comprehension for 1 through 5. So kind of what we'd seen before in the example from Monday. Yeah. Yes. Thank you, Ira. We're going to go ahead and basically stick a for loop inside brackets, right? And so if we want 1 to 5, we're going to go ahead and say for I in range. We're going to start at 1 and we're going to end it at 6, right? So we always want to remember with range, the second value in the second argument is exclusive, as in we don't count it exactly, right? So if we want 1 to 5, we want to start at 1. So the beginning, the first argument is inclusive, second argument is not inclusive. So this is how we'd go ahead and do that. And then the only other thing we need is to now basically say, hey, for this I value, go ahead and kind of just like stick it in the list, right? And the way we do that, we just add it kind of to the front in the format that we want it in. Okay, so I'll just go ahead and run this at the end once we have all the comprehensions done. So here's second up, write a comprehension to produce the cubes of the numbers 0 through 9. Oh, and then the other thing I forgot to mention, we're going to go ahead and time box questions. There was some feedback saying people didn't really like how I kind of just like kept jumping back and forth between questions and the material. So I will be time boxing questions to kind of like right before we go on breaks is when I'll look at Slack and kind of answer questions. So there's a lot of feedback about that, which I'll go ahead and kind of implement. Okay, so now, in this case, we want 0 to 9. So we'll go ahead and start off for I in range 0 through 10. If we know we want to start off at 0, we can just go ahead and get rid of the first argument. In this case, if we just give it a single argument, range is going to default to starting at 0. And if we just did this, right, this would just give us 0 through 9. But now we want the cubes. Now we want the cubes. And so what we can do, one way we can do this, if we want to go ahead and raise something to the power of a number in Python, you use double asterisks, and we can go ahead and say that. So take I from the for loop, the numbers 0 through 9 again. We're gonna basically do the append, but before we even do that, we're gonna cube it, and then this is what ends up kind of getting appended basically into the list. All right. Okay, and then next up, we want to go ahead and write a comprehension to produce the uppercase version of all the elements in some array that we're already given. So telling us a hint, we can use this foo dot, this upper function. So again, the loop we're probably going to want, well, we're going to want to loop through the strings in here. So we can go ahead and say, I'm going to call it S, short for string. Again, doesn't matter what you call the variable right after the for. I'm going to call it S, and we're going to loop through all of these. So we're going to say for S and A, right? So that gives us all of these strings. And now the way we want to return it, again, S, but we want to call this upper function. So again, now we're looping through, we're getting each individual string in this array. That's what we want to append, but before we directly append that, we're gonna call upper on it. So it will call upper on the string, and then this whole thing is basically what gets appended into the list. Okay, next up, use a list comprehension to create a list containing only the even elements the user entered into list X. So what do we need the square brackets to make this work? So there's this input function that's being called here. And this is basically, well, actually, let's run this one. So run this here. This one I called 08 comprehensions. Okay, so we have the answers that we have from up there, and then enter comma separated numbers. So let's say 1, 2, 3, 4, 5. Okay, obviously we haven't implemented anything yet, so that's not going to return anything. But we can see here this input function just basically prompts us to enter some input in the command line. And then that's going to go ahead and take the string we gave it, right? So we passed it this. So we passed it this 1, 2, 3, 4, 5 with commas. Well, because it asked us to, right? So it says enter comma separated numbers. So that's exactly what I did. And then it's basically going to go ahead and split on all of the commas. So if we just go ahead and say, let me say for elem in X, let's go ahead and print that. So let's run the same thing. Oh, right. Finish that. For element X, we'll just give it X. Run that with 1 through 5. Oh, okay. Well, okay. So what happened here? Well, it looks like we got every single, we got the X is the whole array, or sorry, Y is the whole array. We're printing Y. But when we say, okay, so when we say for element X, right, X is actually the whole array. X is the whole array, which is why we notice here we're getting 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We're getting this array. We're getting this array 5 times. Not quite what we want. Not quite what we want. So what do we need to do to get this to work? Again, elem is just that list of 1, 2, 3, 4, 5. So what we probably then want to do is we need to say if the element mod by 2 is 0, right? So this is how we can check if an element is even. So we're going to need that somehow. The other thing we're probably going to want to do is we need to go ahead and also make sure this is an integer. So one way we can do that in Python is with this int function. We'll just wrap this around the element. Oh, I'm sorry, I meant for elem. That's why it's weird. Okay, sorry, let me back up. So there was a mistake I made because I said, So I said for elem in X, give it X. Okay. So what I meant to say was elem, but this is why we were getting this wonky input, right? So I wasn't actually getting each individual element from X. I was actually saying, hey, just put the whole list in, which is what I was getting, which is why, again, that was wonky. So now if we do that, I think that is closer, right? Because now, okay, now we're just getting the list. And now we can go ahead and basically filter those elements out. So we'll say if int of elem modded by 2 is 0, right? So now in this loop, elem, we're taking this. This doesn't actually come through as a number, so we need to turn it into a number. So actually, what happens if we just leave off the int? We just do that. Yeah, we'll see. Well, it's basically saying we're not allowed to do this filtering because this is not an integer. So this is why we need to go ahead and do that. But then once we add that, this should work out fine and dandy. And now we have just the elements, the even elements from what we passed in, because now the filtering part works. Okay. Sorry, so let's see if there are just any quick questions I can answer about what we did so far with just this exercise before we move on. Yes, elem instead of X, yep. Is it okay if you did it this way? Y equals int A for A. Sure. The first int A is just maybe a little redundant, so you don't actually really need that. Other than that, it should be fine. If we did X for X and X, would that get confused? Yeah, probably. Probably. Probably would get confused. Oh, it didn't. Interesting. Not what I expected, but I still wouldn't do it this way, just because you would then probably confuse other people who are reading the code. So maybe the computer's not confused, but other humans reading it might be confused, and that's an important consideration to make, right? Code readability is very important. So even if your code does not necessarily actually confuse the computer, you should also think about, is it going to confuse other people who are reading it? So that's also an important consideration. So I still wouldn't actually do it this way. I still wouldn't actually do it that way. Let's get that back. Okay. Yeah, exactly, Asher. All right. With that one done, let's go ahead and move on to dictionaries. So this one, all right. So we're getting a bunch of these waypoints. So we're given an array of dictionaries, which apparently are these waypoint location type things. So there's a latitude parameter, there's a longitude parameter, and then a name for this place. So we have a couple of these. Add a new waypoint to the list. I guess it doesn't really matter what. So we can go ahead and say waypoints append. We could just give it. We just give it some. lat lon, I don't know, and then let's give it a name. I don't know, SF is the first thing that popped into my mind. So that will go ahead and add that. So we'll have a fourth waypoint now that apparently represents SF. San Fernando, obviously. Okay, so modify the dictionary with the name, name a place such that its longitude value is 130 and change its name to not a real place. It's okay to access the dictionary using bracket notation on the waypoints list. Okay, so we're gonna go ahead and change the very first one. So there's a couple of ways we can do this. One way, probably the most straightforward way, we can just eyeball this and see, hey, the one that's called a place is the very first one. So let's just access it via its index in the list. So now we're accessing this dictionary and we want to go ahead and change its longitude value to what? So yeah, to negative 130. So we can go ahead and access it by this. So now we're accessing this value. In fact, if we just go ahead and print this, should get back the negative 121. Just make sure. Okay, so we're getting that. So now let's get rid of the print. We can go ahead and just now change it to negative 130. Similarly, we want to also change its name, so we can do that. And it wanted us to change it to not a real place, so not a real place. That'll go ahead and change it. Now write a loop that prints out all the fields for all of the waypoints. So let's loop through our waypoints. I'll just call it W in waypoints. So for each of those, let's go ahead and print out the, oops, let's not do, okay, let me do double strings out here. And then in here, we're going to do single quotes. So let's call it lat, close that. One, close that, and then name. Just making sure I got all these parens. I think that's good. So now let's run that. Okay. Cool. So that was the waypoints one with dictionaries. Hopefully that one was relatively straightforward. Any quick questions there? Any preference on why not use waypoint 0 update? No, I mean that's perfectly fine as well. That's perfectly fine as well. Again, lots of different ways to skin the cat. Yeah, that one seems totally fine to me as well. We're using %R on 52. %R is an older way of doing it. So you know, chalk it up to the novelty factor. F strings are the newest way to do template string literals. So shrug. It's just %R is probably going to be less common. It's just probably going to be less common. Okay. So let's leave that at that, and then finally let's move on to the classes exercise. Okay, so continues on with this latitude and longitude theme. So we want to make a class lat_lon to be passed parameters latitude and longitude to the constructor. Okay, so we're gonna make a class. It's gonna be called lat_lon. We need to, of course, go with the double underscore init, which needs self. And then this also says we need to be able to pass it latitude and longitude. So let's call it lat, let's call it lon. And then let's go ahead and set those as attributes, like so. Make a class waypoint that can be passed parameters named lat and lon to the constructor should inherit from lat_lon look up the super method. Okay, so real quick, let's fill this out. So this one says make a waypoint class. Again, it needs to be able to be passed name lat and lon to the constructor, but it should also inherit from our lat_lon class that we just built, right? So the way we specify that, and we touched on this a little bit yesterday, but now we do need to go ahead and add parens after the class name, and we're going to give it the name of the class that we want this to inherit from. Needs to be able to be passed name lat and lon to the constructor. Okay. So again, similarly, we're going to give this an init function, set name, lat, and lon. And what we could do is, again, we could do self.lat equals lat, self.lon equals lon, and self.name equals name. But the advantage of inheritance, the thing that we could take advantage of here is if waypoint inherits from our lat_lon class, then what that allows us to do is call any function on the class that we're inheriting from, right? So lat_lon already has this init function defined that basically already does the setting of the lat and lon attributes, right? So here we're kind of just duplicating that exact same work when it would be just a little bit more appropriate to go ahead and just make use of the functionality that was already implemented on the parent class. So what we can do is we can use the function, the method super, and you can think of this as the parent object, right? You can think of this as the parent object. We'll call this in order to gain access to any of the methods on the parent. So once we do that, again, you can pretend that this is the parent class. So we can then just go ahead and say super init, right? So we're literally calling lat_lon's init method. And this method takes lat and lon parameters. We don't need to pass itself because that's just specifying that this is a method on this class. So we don't need to pass in self. We'll just pass in lat and lon like so. Right, so now again, you can think of super as accessing the parent class. Once you've done that, we can go ahead and call methods on the original parent class. And this works with any other method as well, right? So we could have some other method foo here, for example. We could then go ahead and say super.foo if we wanted to do that. So it's just a little bit more appropriate, again, instead of just like reusing or redefining that same logic, like rewriting these lines, it's just a little bit more appropriate to go ahead and reuse functionality that we are basically already built. Okay. Next, make a class geocache that can be passed parameters, name, difficulty, size, lat, and lon to the constructor. What should it inherit from? Well, I'm going to go ahead and say it should probably inherit from waypoint. We'll have it go ahead and inherit from waypoint. Let's give it geocache, give it our waypoint class to inherit from. Again, as always, going to need its own init method. And this one says it needs self, name, difficulty, size, lat, and lon. And so, again, there's a bunch of parameters that are that the geocache init method has in common with its parent, right? So name, lat, and lon, already being handled by waypoints init method. We're going to do the same thing here again. We can call super, call the init, and we'll pass it the name, the lat, and the lon. And so now, again, we're basically delegating to waypoints init method with these parameters. And so it just runs the whole thing and sets name, lat, and lon as attributes on our class. Right, so now we just have to handle the attributes that it doesn't know how to deal with. So difficulty will be difficulty, and size will be size. Make a new waypoint and print it out. Okay. So let's say waypoint will be waypoint catacombs 41075 negative 121 515. Okay, let's run this at this point. So let's comment this one, print line out. That's not going to work. Let's just run our progress right now. Nope. What's this? 015. Okay. So, yep, we're going to get this object signature back when we go ahead and try to print out waypoint. And the problem now is because we need to basically tell Python, hey, we want to print this class out in a certain way, right? If we don't tell Python how we want this class printed out or any class printed out, this is what it assumes. This is what it assumes. It assumes this weird object signature thing, which, you know, not very helpful. So this is something we need to go ahead and add to the classes ourselves. There's a couple of ways we can do this. We have basically a choice between repr, or we could do string. String is a little bit nicer just because kind of the way it works is if you have a string and you implement string, it basically gives you repr for free. But the other way around is not the case. So if you implement repr, it doesn't actually give you a string implementation for free. So this is just a little bit easier. They do very similar things. I know string forces you to return output as a string. Repr is a little bit more flexible in that it doesn't necessarily require that you return string output. This gives you a little bit more flexible ways to kind of represent the class you're implementing this on. But in this case, we just want to be able to print it out. So string output is totally fine. And for free, we'll basically just get a repr implementation thrown in. So we'll define this underscore underscore str underscore underscore method on waypoint. And the way I'm going to go ahead and structure this, you can go ahead and really you can structure this whatever way makes sense, just so as long as you know or understand what's being printed out. I'm gonna go ahead and do make this in F string. And we're gonna do self name, self lat, and self lon. I think that should be good. Okay. Go ahead and run this now, and we go ahead and get our printed out string. Oh, so I guess we didn't actually don't need that. Okay. So we also want to basically do the same thing with geocache. So this print now works. Let's uncomment the print geocache at the bottom, but we now want to make a new geocache equals geocache. Let's call it Newberry views. Let's see, 0.5, 1.6, doesn't matter. 44, 014. Oh, it gave us actual specifications. Okay, I'll just put those in. Okay. Similarly, when we go ahead and try to print this, right, not quite going to work. Not quite going to work. Oh, okay. Oh, right. So nice thing here. So okay. So we look at what happened, right? It printed out some stuff, and it wasn't in this weird object format, right? So we're printing out a waypoint, Newberry views with the coordinates. So what's going on here, right? So this is a thing we're basically getting for free as a result of the fact that our geocache inherits from waypoint. Basically what's going on here is we're saying, hey, print out geocache here. The geocache class, Python looks at that and says, hey, there's no string or repr method, right? We haven't defined one here. But there is one on the parent class. So it presumes then probably will want to use the one on the parent class and not just get back again the weird object memory format, this one. Which is probably a pretty good assumption. And so again, we get the output from this str method, which again probably better than this. But let's go ahead and implement a custom str method on our geocache. So similarly, call this geocache. And now let's go ahead and give it let's do self name. Difficulty. Size. Okay. And now we do that and we get our proper geocache printed out. Okay. Oh, underscore nitpren. That's a mistake. That's a mistake. We'll need to go ahead and fix that. Jose asking, how do I feel about using star k-wargs using latlon as well? So passed because I hate retyping. No, I agree. There's a lot of retyping here. So you know what? Probably smarter to go ahead and use the KW args. So I definitely don't disagree with that at all. You have to make two different supers if you're also passing in methods from the parent class to the child. You have to make two different supers. Yeah, super just gives you access to the parent class. How far up the inheritance chain does super reach? Pretty sure it goes all the way.
Sean.
Yeah.
I think you can change. You can, if there's a super defined, a super called from each parent or each ancestor, then that super is what I think that's what basically can go arbitrarily far up the ancestry chain, right?
Yeah, I think you're correct there.
Okay.
I think you're right there. So my question was, we're on the 20th child online. Is there a better way of doing that? Not that I know of. Not that I know of. And object-oriented programming has a bit of a reputation for being verbose. So this might kind of tie in with that. Oh, move the code up. Yeah, sorry. Well, let's do. That could be one way of putting it, Asher. Okay, I'll leave the code up. Now we're done with these exercises. Let's go ahead and take a few minutes break. Let me leave the code up. Well, okay, let's do this. Let me just make the timer window real small. I'll still want to leave it up. Okay, so let's do that. Let me reset that. Let's go ahead and come back in 7 minutes. All right. Let's go ahead and come back. Next on the docket, we're going to go ahead and recreate, not recreate, create a more kind of involved example. So what we're going to do here is we're going to basically kind of, should say, we're going to kind of design a store. And again, this is going to be an exercise in OOP. Design a store using OOP kind of methodologies. So let's talk a little bit about what does the store look like. What do we like? What are attributes, or what are, like, you know, things about the store that we're going to want to emulate? What are attributes we care about? What are, well, sure, let's just leave it at that. What attributes we care about and things like that, right? First off, we kind of want to product. Sure. A store needs product. That's a good suggestion. But maybe even a little bit more basic than that. What are things that a store needs? Inventory, money in the bank, employees. Yeah. Again, really good suggestions. Let's go even a little bit simpler. First off, I think, well, I guess you could argue with this a little bit, but I think, you know, we're going to need a name for our store. And let's also go ahead and add type of business, location. Sure. Location. I guess, Nicole, you suggested inventory. Maybe let's call it something slightly different. Let's call it categories of products, or something like that. Departments. Yeah. Okay. So again, a lot of suggestions. But let's start simple. Let's start simple. Right. We don't want to kind of overwhelm ourselves with too many attributes, too many you know, categories and properties and things like that quite yet. So let's just go ahead and make our store class. Again, as always, need your init, needs self. So we said let's give it a name. Let's give it a location. And let's give it categories. I just had an idea. Maybe we should go ahead and import our yeah, let's import our lat long. Sure, why not? Let's reuse our lat long. So let's say from classes import lat long. I don't know if it likes that. It might not like. Okay, let's rename this. I think there might be an issue with the number in the classes file. Okay, we can go ahead and import lat long location. So let's give it a name. Location, which will be. Let's do this. Let's pass in the lat and lon as properties specifically for location, and then we can say location will then be lat lon with the lat and lon properties. Categories will be categories. Let's do that. Let's then go ahead and add a str method so that we can basically kind of, I would say, observe our store instance. we'll go ahead and sure, let's go ahead and print this out. So kind of like what we had earlier, we have it store self.name. Show lat.lon. I guess we didn't actually. Okay, so we never gave lat.lon a str method, so we should probably do that real quick. So let's just say. So we probably want something here as a way to print out. Yeah, because we'll want to go ahead and print out self-location. So we need a way to do that on the lat.lon class. So let's do location. Let's do that. Let's not have the angle brackets. So now that should allow us to do self.location. And then self.categories. So maybe we don't know what these categories look like yet, but well, in my mind, I'm thinking this is probably going to be I'm thinking this is probably a list of strings or something like that. Okay. Let's go ahead and do store name lambda store random location. I don't know. Categories. Let's just say clothes for now. So this only sells clothes for now. Let's just go ahead and test our print. Store.py, store location, clothes. So yes, there's the name. We're delegating to the string method on our location and then our categories. Okay, cool. So that's working. That's working. Let's go ahead and now you know what? Okay, let's actually change categories. Let's change this to departments. I think I like that a little bit better. Instead of categories as a name. Departments makes more sense for a store. So let's do that. So let me change this. So yeah, the clothing department. Okay, let's go ahead and add the ability. So let's say we want to add departments. And the way we'll go ahead and do this is let's take input from the user, have them specify departments. So let's say selection will be input, and we'll say select the number of a department. So maybe we'll want, so let's say user have them specify departments by the departments, let's say index in the departments list. So maybe we'll say clothing is department 0, because that's the first element in our clothing list, et cetera, et cetera. So actually, I guess we'll go ahead and let's add a few more departments. Clothing, cookware, probably one of my favorite departments. Books, and let's do one more, sporting goods. Capitalize sporting goods. Okay. So let's go ahead and then we want to be able to say print the user selected. Let's go ahead and say sure, let's say selection. Let's just mirror it back for now. Let's just mirror it back for now. So if we run that, that prints that out again. Oh, why is that pointing? Why is it printing geocaching? Okay, well, anyway. So 1. Okay, yes, so that's working. Let's add a colon there just for better. Okay. Where did these come from? Store PY. Huh. That is weird. Why were these getting printed? Is it because I comment these out? Will that stop that? Let's see. Okay. Okay, that seems to do it. Okay. So we go back to our store. Let's take that away. And now let's go ahead and say store departments, because we want it to actually return the actual ID of the department. So let's say store departments selection. Let's kill that. Let's do it again. Okay. List indices must be integers or slices, not strings. So we're going to have to go ahead and say int selection, like so. Now if we do that, user selected books. Okay. Cool. Now, maybe there's the possibility that the user types in 10, which we obviously don't have a department for that. So let's go ahead and add some error handling. Let's go ahead and add some error handling. So let's say add error handling so that when the user inputs a department number for a non-existent department, we'll notify them that that department doesn't exist. Okay. Let's do this. So let's say the way we're going to go ahead and do error handling is there are these try except blocks in Python is how you probably go about doing this. So in this try, let's go ahead and say, let's go ahead and do this. So let's move the casting into try, just also because casting might cause an error. Maybe they give us something that cannot be cast to a number. Like maybe they give us some random string, right? they could say, oh, well. Like what could happen is when we say select the number of a department, they type in high or something. So that would break the casting. So what we can do is throw this into the try block, so that if this casting break, basically if anything kind of like breaks inside the try block, it will fall back on what to do in the exception part. So so let's say our selection is going to be that. So now let's say if selection is going to be greater than the length of store dot departments. Actually, so equal. Let's go ahead and say, let's go ahead and print that's not a valid department. Right, because they're giving us an ID for a department outside our store. Else if, let's say, selection is greater than or equal to 0, and selection is less than length of store.departments, then it's in our range, right? We can handle 0, we can handle anything less than the length of store departments. Those will all be indices. So now we'll go ahead and print our statement from here. Don't need the int here now because we already did the casting. We can do that. Let's go ahead and say else. Well, I guess the only other thing then is it's going to be a negative number. Sure, so let's just say, let's say department numbers are positive. Because again, the only way we're going to get here into this else is it being negative. Because again, we're handling anything larger than the length of store departments. We're handling anything in between 0 and the length of store departments. So again, only thing else is negative values. Other than that, we're going to go ahead and raise a value error, because if we reach here, then what happened was the user didn't give us a value that could be cast to a number. So here we'll go ahead and say, please enter your choice as a number. All right, let's see. How do we run this now? So now let's go 3. Okay, that worked. 21, that's not a valid department. Negative 12, department numbers are positive. Cool. So now we have some error handling there. We have a way for users to select departments. Oh, okay. Sorry, looking at some of the stuff here. So Evie made a good point. When you imported classes py, all the executable lines of code executed because they're not in a name. Cool, I did not know that. Akraga. That's a lot of arguments. Ah. Type annotations. Cool, I didn't know that, Mike. That's good to know. That's good to know. How do I feel about using it while for input handling so it doesn't keep closing the input? Yes, that was the thing we were going to add next, Jose. That was the thing we're going to add next. So yes, let's go ahead and wrap all this logic in a while loop so that we can basically keep giving selections instead of having to rerun the program every time. Right, because that's maybe a little bit annoying. You need to break out the loop by returning true. Yeah, we'll need, yes, we'll need criteria to, yes, decide when to break out the loop and stuff. So let's indent all of this over. Let's throw this in a while loop. Sure, let's just say while true for now. That'll go ahead and do that. So yes, when should we break out of this loop? Maybe we can go ahead and maybe the user should be able to type exit, right? They want to go ahead and exit our store. So let's let the user type exit into the selection to have them leave. Okay, so let's say select the number of a department or type exit to leave. So let's do that. So then the best way to okay, so let's think about this, right? Because if they type exit, if we just typed exit now, it's going to get into our try block. It's going to try to go ahead and cast that to an int, right? And so the string exit is going to break the casting. So we're going to have to do this before we even get into the try block. So let's say if selection matches exit, we'll go ahead and return or break, whichever. Other than that, it will try to get in here. Break. So now if we do this, select, user selected sporting goods, 6 is not a valid department, exit, we went ahead and exited. In fact, let's go ahead and before we even break, let's also print a thanks for shopping before we break. So now if we just type exit, gives us a nice little prompt. Okay. Cool. Let's go ahead and flesh this out a little bit more. So maybe what would be nice is we already had location. We already had a class dedicated specifically for location. Maybe we should want a class. Let's add a class for departments. Let's add a class for departments, right? Because it's probably not great to just have them as strings like this. Maybe we'll want to add additional functionality to departments. So let's make a new class called department. And presumably the departments are going to need names, which are probably going to be these strings, right? Name is name. It's probably good for now. Not doing anything else with them. Let's also give a way to go ahead and print these. Our store is brand new, so there's probably nothing in these departments yet. So for now, let's just go ahead and say no products available in the, let's say, string self dot name department yet. Now we'll go ahead and now we're going to want departments to be a list of departments. So let's go ahead and do this. We'll get departments as a string. But what we can do, okay, let's do this. So let's do departments. Instead of just giving it the list of strings as the departments, let's go ahead and use a list comprehension, because what we can do is we can say department, pass in on the name, let's call it D for D in departments. For D in departments. We can get rid of that one now. Right, so now we're looping through the departments string, putting each one in a department instance. So now we have all of these in the list. Okay, so what happens when we run this now? We go ahead and, okay. So we selected this, type error can only concatenate string, not right. So here, okay. So we're getting to this point. We're giving it a selection. It's reaching into the store, into the departments list, and it's trying to, well, it says here it's trying to concatenate, well, we can only concatenate strings, but it's trying to concatenate, I guess, the actual instance to string, which doesn't work for good reason. So let me get rid of that line. So let's just actually go ahead and just print, let's just print the string representation for our department. Right, so instead, let's go ahead and reach for the department, basically call print on it. So presumably we'll get whatever statement we have here. Okay, cool. Does that work now? And again, if we give it 10, not a valid department. If we give it a valid department, it just goes ahead and defaults to the string method we have here, no products available. Again, we don't have anything there yet. Okay, so let's go ahead and change that. So we're going to want products in here. So it'll be some list of products. But let's do something similar. So let's have a product class for an individual product. And so again, let's give this the name of the product. We'll probably want the price as well. And again, let's give it a string representation. So let's go ahead and say return the name of the product, costs, let's say dollar self.price. So we'll list that off. So we'll probably want the same thing, right? We'll want, let's just do that. And in fact, actually, let's do let's do, again, the same thing with what we were doing with department. Let's do product P for P in products. So products also presumably, let's have it say, let's just, okay, actually, let's go ahead and take Mike's suggestion of doing a type annotation. So I guess what we could do is, could we give it a tuple type? Could we say string name with int price? Would that work, Mike?
I'm actually not sure, but if we could try it, you might have to do from typing import tuple with a capital T, Sean, because like the one that I had done previously, you had to import list, and I had list and then bracket, like the list was of type str. I'll go Google this right now, but yeah, I mean it probably works. Or it probably works. I just don't know the syntax for it.
Okay, so let's actually save that for later. So let me just annotate it with a comment. And yes, so is there any particular place you want me to go over again, Harris? Or any place you need me to scroll to?
I'm just trying to add the department and products classes.
Got it.
So
here good?
Yeah.
Sure.
Can you scroll down to the print that you made at the very bottom, store.departments.
Okay, yeah, let me scroll down real quick for Asher. So you're talking about here?
Yes.
Okay, is that good? And then, did you get what you need? So I can scroll back up. I'm going to assume yes. And again, I'll post all this code in the Notepad channel afterwards as well. But here, let's go ahead and say products will just be, products will be a list of tuples. So I want tuples just because we're going to have name and price. List of tuples with signature, string and int. String and int. So the string for the name and the integer for the price. So actually then, if that's the case, so now that means each individual P is a tuple with this signature. So what we can do then is, if this is a tuple, we're going to pass it P0, comma P1, the two different tuple elements. Scroll down to the else if statement. Here. Why not pass it star P? Why not pass it star P? Okay, we can try that. Will that go ahead and basically like map the two tuple elements of price? Unpacks the elements. Okay. Okay, so it'll unpack it. The first one will be the name. Got it. Okay. Okay. Are Krog asking why a tuple? Why a tuple and not a list? Why a tuple and not a list? I think it's just a little bit more appropriate because with a list, there's more of a notion that like a list, like you can have a bunch of lists where the lengths are different. With a tuple, there's more of this notion that every tuple that you get is going to kind of be the same size, if that makes sense. So it's like if I do it with a tuple instead, it's more concrete that each tuple is going to have this string and int signature, and that's like not going to change. Yeah, that being yes, the fact that tuples are immutable kind of contributes to that fact. Right, you can't change a tuple, which is kind of what we want here, right? We're basically saying, again, every product is just going to have its name and its price. We're never really going to have anything more than that. I mean, maybe we'll regret that choice later if we opt to change it. But I think for the sake of this example, we're just going to go ahead and say, hey, every product's just going to have its name and its price, and we're not going to change that. So a tuple is just like a little bit more appropriate there.
Sean, so the type signature for products is probably just I'll type it out in the chat. It should be : lists with a capital L, and then you just say, because product is the class you define, so it should just look something like this. Yeah, and at the top you have to do from typing import list.
Okay. We'll not do that here, but this is definitely good stuff for when I go ahead and update these guided projects.
Yeah.
So
also the type annotations, they like if you have the wrong annotation, the program will still run because Python doesn't have like compile time like type checking or whatever the hell it's called. This is just like it only creates like autocomplete hints and stuff when you're typing stuff in
gotcha.
In like yeah, in the editor.
Gotcha. Okay. Cool. So made a product. Again, we're passing this list of tuples into a product instance. We're making a product instance for each one. So we're given name and price, and we have a way to print that out. Okay. So let's now okay. So now we need right. So we need to pass these in. Just so this still actually works, we can add a optional argument. So that'll fix the issue for now. So if you haven't encountered this yet, what you can do is say, if we don't specify anything for products, default to whatever is after the equal sign. Oh, star on, okay, so the star here is just saying, for each P, this is gonna look something like this. It's gonna have the signature. It's gonna be a string and an integer. And the star is just saying, basically unpack what's in the tuple. Right, so it's basically gonna say, unpack the two elements inside and basically give them in the order that they came in. Right, so the first thing is gonna be the string. That's gonna go with name. Second element, int, is gonna go with price. So it's the same thing as if we'd said, P0, comma P1. Right, so these are basically doing the same thing. Right, so again, it's just saying P has some things inside of it. Let's unpack them. It pulls them out and kind of hands them in the order that they were given. So it's a nice little syntax trick. I guess well, personally, I think I still like this just a little bit better just because it's more explicit, but sure, we'll go ahead with the with the unpacking syntax. And so now here, we made a department instance. We're not passing in any products. And so now that is fine because we're giving it an optional argument. There's nothing in products. So this is just going to come back as an empty list. So yes, it's like JavaScript destructuring. That's a good analogy. We can go on, but again, people, I guess I want to slow down a little and see if everyone else is on the same page. Right, so again, let's just circle back to what have we been doing. We're going through an example of running through designing this or modeling out this store thing. Right, so again, we started off with just the store, you know, gave it stuff like name and location and departments. And initially, again, there were, you know, store being the only class, we were representing departments by just like strings, right? Which works, but doesn't allow us to kind of model what a department really is, right? Because the only representation we had for a department was just the string, right? So it works, but it's not very useful, right? Once we got that going, we added in a little bit of a flow to allow users to select a department, again, to kind of like emulate a shopping experience type thing. So the loop down here handles that whole flow, right? Handles that whole flow. Adding things like, well, you get to select a department via its index, and we were getting that by pulling it in from calling input. So the user got to type that in. Right, so again, this whole loop here is just a flow for getting user input, printing back what they were or what they'd selected. And this just keeps running in a loop until the user decides they want to exit, right? So if they typed in exit, we print a little message back. We break out of this loop. That goes ahead and ends the program. There was some error handling here that we were doing. I just want to kind of reiterate again what the error handling was doing. So again, with this try except syntax, this is how Python handles error handling. Yes, I'll do that next, Nick. So with the error handling, mostly this was catching whether the casting would break or not. So again, you can think of with a try except is like, hey, anything in here that has the possibility of returning an error defaults to the accept clause. And really the only thing that would cause an error is the casting. Because nothing else here, everything else here is basically being handled, right? So if we look at just the if else part, this is just us kind of handling the selection with the index, right? So we determine that selections is a valid number, and then we're basically trying to access the appropriate department by that selection index. So again, the only thing that could go wrong here is the casting. That might cause an error because the user is able to give selection as anything, might not be an integer. So if we give it a string hi and it tries to cast it with int, that's going to break. So if that happens, then we'll exit the try block, get out here and to accept. We'll call it a value error just because you didn't give it the appropriate value. And we'll give it the message, the appropriate message there in that case. Think of it as, I kind of think of it as a flag to say, so there's a whole bunch of different sorts of errors. So actually, let's see. Python errors. There's a whole bunch of these. Built-in exceptions, that's a better name. So these are going to be basically all the sorts of errors that you can raise from a try block, right? So, exceptions. So like assertion error, attribute error, we're going down, we did the value error. Yeah. So raise when when operation or function receives an argument, but it has the right type, inappropriate value. Okay, so that kind of indicates that value error is actually not the correct exception we should be raising here, right? Because we're trying to raise an exception specifically when the user gave us a input that we're not able to cast to a number. So I think maybe what would be more appropriate is something like some kind of like type error. Is that a thing? There is type error. Let's see. Okay, type error raised when an operation or function is applied to an object of inappropriate type. Okay, so this seems a little bit more appropriate. This seems a little bit more appropriate because it's not a question of the value, it's the fact that the user gave us something that could not be cast to a number, which comes back to kind of like the type. So I think this is slightly more appropriate than value error. Okay. So that's kind of what's going on with this loop here. And then there was also a question about the list comprehension. So let's look at the store one, right? So again, in the store constructor, we're passing in departments. As of now, those are just strings. We're passing them in as just strings, right? We could do this a different way. We could wrap each of these in department, because with department, that takes in a name. And that's what all of these strings basically are. They're the names of the departments. So we could pass them in to this instant here, but that would necessitate us saying department, department, department around all of these strings, which you know, is a little annoying. So the way around this, what we can do is we can use a list comprehension to just say, hey, let's make a new list where we're going to take every single string. So D in this case, for D in departments, that's going to be a single one of these strings. And let's take that and wrap it in the constructor, right? So again, this is doing the exact same thing as if we had added department around every single one of these strings, but you know, saves us a bunch of those keystrokes. Oh, what did I comment out in the class file to prevent importing the other class? I literally just commented out the print statements, right? So what we were seeing was these were uncommented. And then what Evie was saying was basically because we imported from the classes file, it's actually going to go ahead and run all of this code. Which is not what we wanted. So a couple of ways we could fix this. Actually, one other way we could fix this that she kind of touched on was we can throw all of this in a special statement that looks like this. So let me see real quick. If we try this now, sorry, let me exit that. Let's start it up again. Okay. So this works also as a way to basically not have this all print out by wrapping it in this weird looking thing here, which I actually didn't know. So I didn't know that if we had it out like this, that it would actually just run it all. So that was good to know. So again, 2 ways we were able to handle it. You can just comment these out or wrap it in that weird if name equals main. This, how would I describe this? It's like, ooh. Nobody's coming from a language where there are main. Does Swift have main functions? I don't actually know. I guess for our purposes, you can think of it, this is only going to run when you execute this particular file now, right? So like if we still go ahead and run Python 3 classes, like this all still prints out. All the stuff we have here still runs, which is good. That's what we want. But when we go ahead and import it into another file, now it's not going to run, which is nice. And again, if we didn't have all of this inside of this if name equals main statement, then it would run when we did the import. So yeah, what does that do? Again, there's a much deeper explanation, but again, for the purposes of our use case here, you can kind of just think of it as, let's just execute this code when we're actually executing this file. Otherwise, let's not actually run all this code, which again, kind of what we want. Because again, otherwise, when we didn't have this in the if name equals main statement, it would run when we did the import. So. Oh, okay. Oh, okay. That's a great explanation. Wait, KJ, since type error is now breaking it? What do you mean by it's breaking it? I'm gonna type a string in, it breaks. Missed that part. Okay. Okay, so it is saying you actually want a value error here. Interesting. Okay. So it actually is telling us it wants a value error. Got it. So when's an appropriate time for a type error then? Okay, let's see. This exception may be raised by user code to indicate that an attempted operation on an object is not supported and is not meant to be. If an object is meant to support a given operation but has not yet provided an implementation, instead of passing arguments to the wrong type. Passing arguments of the wrong type, for example, passing a list when int is expected, should result in a type error, but passing arguments with the wrong value. And the value error. That's weird because this is kind of describing what we want, right? Because again, what we're seeing is similar to this example they're giving here, except with us, it's passing a string when an int is expected. Okay, I guess it's a little bit more subtle than that, right? What we want. Okay, it's okay. So I guess what's going on here is we can receive any string, but only a certain set of those strings can be successfully cast. Okay, so it's a little weird because we are accepting a string. We are accepting a string input. When we run input and it fetches input from a user, that's always going to be given to us as a string. So like the return type for input is always going to be a string. And so we can think that at any point, like at this point in time, right after input is run, selection's always going to be a string, right? It could be a string with a number in it. So like it could be quote 1, it could be quote high, 10, whatever, right? It could be any of these, and those are all fine. Those are all fine. So I think the argument now here is a string is the type we want at all times. A string is always going to be the type we want, but only certain values of strings should be cast, should be successfully cast with the int function. So okay, so I guess that would be the argument for you don't actually want type error, because again, the type that we're looking for is a string. And so we want to raise an error when we're getting a string whose value cannot be cast into an int. So I guess that's the argument. And it's a little bit pedantic. But I don't know. But that would be that's how I would kind of rationalize that, right? So again, it comes back to input. Whenever we fetch this input, like even if when we type in, even when we type in like a 3 here, and we give that is always entering the program. That's always entering our code as a string. It's a string with, it's basically quote 3, right? It's coming in as quote 3, but it is a string. But it is a string, right? So again, when input runs, selection's a string. We hit this if block, selection's still a string. And then we go into this try block, we try to turn that string into an integer. So int is expecting a string, but only some of those strings can be turned successfully into integers. And so when that breaks, that's because the string did not have a particular type, a particular value. What if we typed 1 space 1? Okay, let's try that. Let me exit that. Let's try that again. So if we type 1 space 1, well, the question is this a number? And so no, it says Python doesn't recognize this as a number, right? Because it's ambiguous whether this should be 11 or should it be 2 1s? You know, so it's not clear. And so Python decides, I'm not going to make that choice for you. I don't know what you mean, which is probably the right thing to do here. So that's a programmer error because you weren't clear enough with telling the program what you meant. Python's sassy like that. Every programming language is probably going to be like that. It didn't break for you, Jonalyn. Jonalyn, I'm sorry if I'm messing up your name. Interesting. Let me see. We have another 10 minutes or so. We could go on, but I don't think we'll really get anywhere else in 10 minutes. Let's do this. Can we go over to this project? Yeah, sure. That's probably a better thing to do at a time. The last 10 minutes. Oh, I'm sorry. I totally forgot about the break. I totally forgot. Second break. Let's just really quickly go over the project, and maybe we'll leave a little early. So I'm sorry about that. I totally slipped my mind. Okay. Here we're going to be building a text-based adventure game. It's going to be pretty similar in a sense to what we've been building with this whole products thing. It's going to be pretty similar in a way, right? So similar in the sense that there's going to be a loop where we're always going to be receiving input from the user. It's just that in the case of this adventure game, it's, you know, typing in particular commands to say, hey, let's go, for example, north, south, east, or west. Basically, it's like, you can think of it like you're in this game world where there's a bunch of rooms. And your character starts in one location and you're able to kind of travel between rooms. So again, the structure is going to be similar to what we've been building up here. So it's this combination of this game loop that will allow the user to type in commands, along with kind of combining that with different classes that represent things like rooms and objects and your character and items to pick up and things like that. Like really, this project is meant to be pretty open-ended in the sense that there's not too many requirements. Well, I guess there's an argument to be made that maybe there are a lot of requirements, but it's meant to be pretty open-ended, as in, hey, like we've had people in the past who are like, oh, I want to add enemies and I want to add in some kind of combat system. I want to add in like items like potions that'll heal me or heal my mana if I go ahead and use it. Add like scoring and a whole bunch of different things. But structurally, it's going to be similar to this. Again, there's the logic that handles the loop and handles receiving inputs, and then the classes that represent all the different things in the game that the user or the character interacts with. Try to add products to a department. Sure. Let's do it this way. Okay, so let's do, we have our store. Because we then go ahead and do okay, just thinking of, okay, I'm going to do this. I guess one thing we could do is to, okay, so we're going to need to do okay, how about this? Let me flesh this out a little bit more, because I need to kind of figure out the best way to go ahead and add products to a department. We'll pick this example up tomorrow. So tomorrow I'm thinking an add product method. Yeah, that could be a good idea. Actually, that's probably what I end up going for. So let's leave the example here. We'll pick it up again tomorrow. So tomorrow what we'll probably do is finish up this example. We'll go ahead and I'll live code a little bit of the beginning of the adventure game as well tomorrow. And then maybe if there's time permitting, I don't know if anyone still wanted to see some of the solutions from part 1 of this week. If people did want to see some of that, let your TL know, or you can let me know directly, like, hey, I want to, go over some of these exercises, and we'll try to carve out some time for that as well. That's what I'm thinking we'll go ahead and do tomorrow. And I'll go ahead and post the code that we worked on today in the Notepad channel. Cool, thank you, Vinny. Okay, any other last minute questions? Again, sorry for forgetting the break. Sometimes I just totally lose track of time. Sure. Yep, agree with that, Troy. For sure, Spencer. All right, thank you guys. Yeah, have a good rest of your day, guys. Again, been seeing lots of good stuff in the help channel. So that was great. Continue to do that for sure. And I will see you guys tomorrow. Thanks, guys.